Our project is about object detection with YOLO V3, and our team member is Royu Wang, Siqi Jiang, Juntao Feng. So, and here's our presentation. We like to implement our presentation into the following 6 parts. Let's start with the first part overview. First, let's talk about the goal of our presentation. We are aiming at to detect cars, trucks, and pedestrians, these 3 class things accurately in a single image and given bounding box with YOLO V3, so we can classify them and detect them. And actually, YOLO V3 has already existed, so we will not only focus on YOLO V3, but more important, we will put more focus on some innovations. And here are 4 innovations. The first one is classification head label smoothing, and the second is data pre-processing, and the third is image mix-up, and the last one is change loss function. With these 4 innovations, we can improve our results by improve the accuracy. So to start with the project, we first would like to do some preparation, and the first is about the data set. Apart from some pictures taken by us, we downloaded most of the pictures from Udacity, and actually we like to train a model to detect things accurately, so the requirement for the trained dataset is really large, so we use about 6,000 images. And apart from the images, we also downloaded the annotations to train, which is stored in TXT file. And here is an example of the TXT file. And here is an example of the image And actually, this image is really what we want, because there are cars, trucks, and pedestrians in one image, so it will really good for us. And actually, as we know that the target TXT file is not the target TXT file is not the original file, so we must do some format converting. We convert the original TXT file into XML format, and which is a general format and can be converted into any other format. And then we just convert an XML format into the target TXT format. And here is an example of the XML format. In XML format, first we have the name of the picture, and then we have the size of the picture, and then the bounding box, the coordinates of the bounding box. And here is an example of the target TXT format. It just includes the coordinates of all normalized central points, and also the coordinates of the bounding box. And after the preparation, we must do our baseline. And here's about the baseline.
Then I will introduce why we choose YOLO V3. First, compared with faster CNN, YOLO V3 is much faster because it have much less number of anchors and thus do not need to train them. YOLO V3 has only 9 anchors and they are fixed, so this can save much time for training. Secondly, compared with YOLO V2, it has different loss function. For example, YOLO V2 chose MSE as the loss function, while YOLO V3 used softmax to get the labels. Then YOLO V3 used logic regression idea instead of simple classification, and this will give us a higher accuracy. Finally, depend on the special structure of YOLO V3, which use a network is similar to feature pyramid network, and this structure can help us detect smaller objects because it have 3 different scales, and this gives us a higher accuracy. Here we show you some photos of the structure of YOLO V3. You can see here it is followed by a darknet 53 without fully connected layer, and followed by a channel which can help us keep the small information from the previous layer. This will help us get a higher accuracy. After that, I will show you the calculation of the parameter of YOLO V3. The 3 here represent the output 3 predicted bounding box, and the 5 represents each box has 5 parameters, and here is what the final amount of parameters. Then for the baseline, we use the pre-trained model darknet53.cov, and its weights are already trained, and we changed 2 things. The first one, we changed the number of class to 3, and the second one, we changed the number of filters to 3 times number of class plus 5. That is 24 in 3 different places. Then I will show you a result. As we can see in this picture, the bounding box is successfully bounding all the cars in the image. However, the probability of it is not very high. For here, the car can be detected as a car with probability only 0.6, which can be improved. As we all know, the most important part of our project is the improvement. First, we did the data preprocessing part. Because we choose UT as our data set, and it's a very imbalanced data set. As you can see here, almost all the labels are cars, and few of them are trunk or perceptron. To balance the data and improve generalization of the model, we made an augmentation for our data set. And here is the technique we used. And let me show you some results for this one. By the way, for the random corp, because it's too random and sometimes it will lose the object and do not help us improve the model, so we did not use this method, and we only use other 5 methods for our data augmentation. And then welcome my teammate.
To my part, I want to introduce some important improvements in our project. The first one is the coherent image mix-up. This idea is from this article, Bag of Freebies of Training Object Detection Neural Networks. As you can show the picture, we can do some mix-up between some of the pictures in the dataset with one picture in the dataset to do data augmentation. The mix-up has been proved successful in elevating adversary presumptions in classification networks. As we did in the project, we use 1,500 pictures with one picture to do the mix-up, and we get another 1,500 pictures. So this is a good idea to regularize the neural network to favor some simple linear behavior by mixing up pixels of interpolations between pairs of training images. As we can show that the model can be more vibrant and coherent. The second improvement is the change loss function. Usually we use L1 norm or L2 norm to as a loss function. As we can show the picture here, they have the same L1 norm or L2 norm. However, they have a different IOU because they have different ways of overlapping. So we introduce a new concept, that's the GIOU, which is generalized interception over union. GIOU is equal A union B over A intersection B over A union B, cause sometimes the IOU cannot help us to know the distance or the ways they are overlapped. So we can use GIOU to help us to get the better inception about the distance and the ways of different overlaps. Now I can show you some different between IOU and GIOU. Come on. Okay, as you can see, as you can show the picture, we predict the bounding box is here, and here, as you can see, they are different. However, the IOU is 0 in the same because the A intersection B is 0, so they cannot help us to know the distance between the predicted bounding box with the true grounding box. So we introduce the GIOU to help us to know the differences. As we can see, the first union section is can be shown here, and the second one is here. So they are different. It's a good way to help us to know the differences. Oh, go. Okay. So so I'd like to introduce the third improvements of our projects. That is the classification head label smoothing. As we all know, we use the softmax to produce to know the classification of the labels. When the probability is 1, we know that this is true. 0 is not the label. However, sometimes our model is too confident with the prediction. So we want to reduce the model confidence. We introduce the head label smoothing. That is Q equals Q times 1 minus epsilon plus epsilon over K. The K is the number of class, and epsilon is the small constant number. That's a good way to help us to reduce the model confidence, because sometimes the label is not true or there are some wrong with the classification. So this is a way to measure by the differences between the largest and the smallest logists. Now we can show some evaluation of our strategies applied in a project. At the beginning, we can show that the baseline result is here. The bounding box is true of some cars, however, the probability is low. And we did some improvements. We can find that the trunk can be predicted here, and the probability over the same car can be improved obviously. So the last part of our project is the difficulties. That is because the imbalanced data. So we did some data augmentation to help us to get the balanced data, which help us to training the process good.